Hello, everyone, and welcome to Oracle DatabaseWorld AI Edition. The presentation today is on JSON Relational Duality Views. My name is Julian Donchev. I am the product manager of JSON and POSQL at Oracle Corporation. I work for the database group. I run a blog on the internet, database blog. You can very easily find it by Googling my name. The presentation today consists of 5 parts. Here is the agenda for today. First, I will cover what is good and what is bad with relational databases, with the relational format. And then I'll do the same, the good and the bad, for document stores, in particular JSON document databases. And then we'll consider how we can combine the good from both. Next, we'll cover JSON relational duality, which is the main topic of this presentation. And then we'll go over the different benefits of JSON relational duality views. Let us start. Have a look at what IDC have to say about JSON relational duality. It is a truly revolutionary solution, feature, perhaps one of the most important innovation in information science in 20 years. And by far, this is probably one of the most important features of Oracle Database 23 AI. Let us start with a simple example about conferences. In conferences, we usually have 3 main entities: one for attendees, one for sessions, and one for speakers. At a conference, an attendee can attend several sessions, and a session can be attended by many attendees. A speaker at a conference at the same time can only present one session, but a speaker can have different and several sessions at the conference. And if we look at the tables behind those entities, we have the table attendee, the table session, the table speaker, and a 4th table, which is a mapping between attendees and sessions. Those tables, they have constraints. Every table has a primary key. There are foreign key constraints between the tables, as you can see from the slide. Looking at this model, let's see what is good. We have no data duplication, which brings consistency. And we have the flexibility for different use cases using SQL. 1, we can only select the columns that are needed in a SQL statement. We don't need to run a SQL statement against all columns in a table. Also, a query, a SQL statement, can start at any table, and it can include any other tables. We can join tables. And as an example of running SQL, we can create the schedule of an attendee, the schedule of a speaker. We can create the complete session catalog. We can run SQL statements in order to get the sessions with most attendees, the speakers who have most sessions in the conference, and so on and so on. And the relational model is good. It relies on the optimizer, the cost-based optimizer. But let's look at what is bad with relational. We have to define all tables in the database, not just the tables, but all the columns in every single table, including the data types of every single column, which of course requires quite perfect upfront knowledge. And what comes first is the schema, the data comes later. This is hard to evolve. It is non-schema flexible. And if we try to normalize, normalization breaks business objects into many tables, meaning normalizing the database. On top of that, SQL usually is not integrated into programming languages. SQL is a string or can be generated by an object relational mapping. Let's look at an example, an application development example, a conference schedule. Developing applications using normalized tables in a relational database is very flexible, but there is a reason why it is not always easy for developers who develop the application. For example, if we want to build Jill's schedule, a developer must run database operations on each of these four tables: attendee, speaker, session, and the mapping table. Well, is that really what developers want? Ideally, the developer would want to build the schedule of Geo using one single simple database operation, meaning with one SQL statement, for example, to get everything in one go. Let's look at JSON, at document databases. Well, first, looking at the attendee schedule, we have one object per attendee. As you can see here, for Geo, we have one JSON document, which contains the ID, the name, the company, and the schedule, the conference schedule. It contains every session which Geo is attending, SQL session, Node.js session, and the information about those sessions. Looking at the session catalog, we also have one object per session. Looking at the JSON documents on the right side, we see that for the SQL session, we have one JSON document. For the Node.js session, we have one JSON document. And also, if we look afterwards for the speaker schedule, we also have one object per speaker. You see for Adam, one JSON document, for Claudia, one JSON document. Well, looking at what is good in that and what is bad, first, the good part is that the information is in one object. Usually, it can be retrieved by developers with a single get operation from the application code. You do not need to know SQL, you don't need to use SQL, and it is schema flexible, meaning data is first, schema is later. But single hierarchy only is possible for simple use cases. And embedding causes always data duplication. It's hard to keep consistency, and it's even harder to optimize. Well, if we try to put in summary everything that we have discussed until now about the relational data model and the document data model, we can say that the relational data model is ideal as a storage format. Why? Due to the power of normalization, which eliminates data duplication in the database and provides consistency and efficiency. However, the relational model is not ideal as an access format for applications. Why? Since applications process data in terms of hierarchical objects that require skills and effort to map to rows and columns, which means you need to write joins, you need to write subqueries, and so on and so on. Looking at the document model, such as JSON, it is ideal as an access format since it is hierarchical. It makes it easy to map to application objects. However, JSON documents are not ideal as a storage format since different documents in the database can repeat the same data, resulting in data duplication and potential inconsistency, a very problem the relational databases solve via normalization. Well, how can we or can't we normalize JSON? Then the same way as we normalize relational tables. Let's have a look. Let's consider the schedule for Geo. The schedule document on the left side, it can be changed to reference a separate attendee document instead of embedding it like we did in the first place. However, this will need to reference a separate session document, which references a separate speaker document. And you can see what happens on the right side of the slide. When documents are normalized, their simplicity is lost. Normalizing documents actually will produce the worst of both worlds. The document structure that you see now, it mirrors the normalized table schema. Have a look at the slide, the right side on the slide. Actually, all happens without gaining the power of SQL and relational at the database level. We've lost the simplicity of documents at the application level. Not to mention the performance. Performance suffers, and it's because of reference chasing and because of loss of shard locality. Not to mention referential integrity, which must be enforced by every app, which can be tricky, complex, and difficult. This is about the fragmentation of document databases. And looking at the big picture now for documents, well, documents are great if we have simple applications. And often in the beginning of the life cycle, applications are simple. However, at one point, they become more and more complex. And looking at here at the X and Y axis, the X axis represents the case complexity, and the Y axis the benefits. We can see that in the very beginning, when documents and apps are simple, JSON delivers the benefits. The more complex the application becomes, it becomes even hazardous, as the applications eventually at one point will get more and more complex. And because of that, many data experts, they think of or consider pure document databases being an anti-pattern. Let's have a look at the big picture of the relational model. In the beginning, the benefits are low because relational is not as easy as documents for writing simple apps. We see the power of relational when applications becomes more complex, when their complexity increases. And eventually that happens with almost every application. With the Oracle database, we deliver the best of both JSON and relational. Developers can choose the data format that can maximize the benefits in each case. So in the case of simple complexity of applications, use JSON and use relational. Otherwise, when the application gets more complex, well, this is great, but the question is, can we do even better? What would we mean by better? We don't want to choose relational or document. Why can't we get the benefits of relational plus document? Let's look at what those benefits are. For relational, we have the use case flexibility, we have the queryability, consistency, and space efficiency. If we think of documents, the benefits are the easy mappings to language types, the agile schemaless development, the hierarchical data format, and the standard interchange format. Can we get the benefits of both? And meaning for every use case, not just for the simple, for the complex use cases? Well, it is here. And we call it JSON Document Relational Duality. With JSON Document Relational Duality, data is stored as rows in tables. And it can provide the benefits of relational model and SQL access, meaning that we can run complex SQL for reporting, for analytics. And on top of that, rows can include JSON columns, which will store data whose schema is dynamic or evolving. And data can be accessed as JSON documents to deliver the simplicity of the documents. Here is how we create JSON duality views in Oracle Database 23 AI. It is very simple. The structure of the duality view mimics or mirrors the structure of the desired JSON document and makes it very simple to define. As you can see from the syntax, it is very similar to the syntax of creating views. Just we use familiar GraphQL syntax. Here, with this command on the left side, we're creating the attendee schedule. And we create it in the following way. We use the attendee table from which we extract the ID, the name, the company, and then the schedule from the attendee sessions. Here we can specify updatability rules, meaning the attendees can update their own schedule, look at the update clause, but they're not allowed to update speakers, rooms, anything else. They can update only their own schedule. Also, we can specify when properties in a nested objects should be unnested into the parent using the unnest keyword. Let's look at an example of using duality views. From the duality view, we can access the underlying tables, and this will return Jill's schedule as a single JSON document. Look on the right side. This document has all the data which is needed by the use case. It contains the ID, the name, the company, and the schedule, all the sessions, the times of those sessions, the rooms, and the speakers. On top of that, it has the IDs, which are needed to update the data in case an update is needed. We can access the duality view either using SQL, for example, through SQL Plus or SQL Developer, or you can use document APIs, for example, Mongosh. That brings extreme simplicity for developers. They are very, very simple to access. You just have to get a document from the view. If any changes are needed, you make the changes in the document and you just put the document back into the view. Have a look at the picture on the right. What happens is that the database automatically detects the changes in the new document, and it will modify the underlying rows in the tables, in the relational tables. All duality views that share the same data will immediately reflect the change because they are based on the same data. Developers no longer need to worry about inconsistencies. As I said, the database will automatically detect when the database data, which is underlying document, has changed between the initial document read and the subsequent write. And if in between a change occurred, then the write operation will be automatically rejected and will return an error. The application can then reissue the write based on the changed data. This is something what we call optimistic concurrency control. Let's look at the end at the benefits of JSON Relational Duality Views. First, regardless of the row, anyone can work on the same data. Regardless if the person, the developer, is expert in NoSQL and in JSON and doesn't know SQL and relational, or vice versa, if it's somebody who is expert in SQL and doesn't know much about JSON. They can work on the same data set, whether JSON or relational, and they can also build blended applications. And developers can use the JSON relational duality to efficiently join relational and JSON, join relational and semi-structured data. Second, data consistency and integrity across data models and use cases as data is always current, with no lagging and stay on it. Those are extremely important benefits. 3, data stored in duality views can be accessed via SQL, REST, document APIs, for example, MongoDB, Compass, and many languages and driver tools. It gives developers broad choice for all use cases. Another benefit of JSON Relational Duality Views is the performance. It brings better database performance and scalability for those mixed workloads, relational and semi-structured. Next, another benefit is that the duality views eliminate the need to write complex object relational mappings outside the database because the app developers can now directly map programming objects to duality views. And last but not least, duality views are programming language independent, whereas object relational mappings support only one programming language. All that makes application development very simple and agile. And this architectural model provides the best of both worlds. The use case simplicity of JSON, along with the multi-use case power of relational. Where to get more information? You can check our live labs, our live SQL, oracle.com website, our documentation, or directly contact the product and the development managers either via X, Twitter, or directly via email. With all this, I would like to thank you for listening to my presentation, and I wish you a nice day. Thank you very much, and goodbye.